I'm trying to have a variety of things. She just got a partial to it. Okay, hey. Find the limit as x approaches infinity. Sorry, left half deficit, which means find the limit as x approaches infinity. So let's write that down. So we got the limit. X is approaching negative infinity of this function f, which is going to be equivalent to finding the limit as x approaches negative infinity of a much simpler formula. Raise your hand if you know what the much simpler formula is going to be. You're following the flashcard, you're comparing terms that add. And you're able to create a formula inside this blue box that is different than this formula in the black box, but the limits are identical. That's what we're doing. So what goes inside the blue box? What do we find the limit of? We compare terms that add, we get a brand new formula. What's the new formula? Got about half of you. Hoping for more. Keep waiting. Now we're doing better. Last time I had you discuss, more hands went down than came up, so maybe we won't do that again. At least not today. So 2 points if your hand is raised. Brinley, what would be the new formula?
2x over 3x.
So you're comparing terms that add, you would simply end up with 2x divided by 3x. Brinley gets 3 points. Question? Oh, please.
What does it mean when it comes to terms that add between?
So it's steps. So step 1 is, if x is approaching positive or negative infinity, we want to compare terms that add. The 2's part of the next step. So look at that. That's okay. So what we did, Kate, is we said, hey, as x gets bigger and bigger, 2 times x plus 3 is going to become closer and closer to being really just 2x. Because adding the 3 is going to make less and less significant. Does that answer your question?
Yeah.
Okay. 2 more for Kate, please.
Why did we write down the limit of x and then just rewrite it again?
Oh, awesome.
Why don't we just do the 2x over 3 from the beginning?
I think it's critical that you not forget, 3 points for Spencer, that we are finding the limit of f. That's the goal. How do we find that limit? We go find the limit of a different formula, right here. As we've emphasized, the black formulas are identical, but they're not the same as the blue. They're different. But the limits are the same. So you need to show the grader that you understand that finding the limit of f is the same as finding the limit of this. If you jump right to here, the grader doesn't know that you really get it. He just thinks you're memorizing what the teacher didn't copy, and they won't give points for that. Question. Awesome. So, just for clarity, so this step here, Spencer, is not required. This is just for clarity. As x becomes increasingly negative, say it out loud together as a class. What's the yellow box going to equal? Say it. Yeah, the yellow box is 1. So this limit is 2/3. So say yes or no, please. Does this function have a horizontal asymptote? Yes or no? Say it.
Yes.
A little weak, but Sophie wins for saying it first. Yes. If the limit as x approaches negative infinity is a value of 2/3, then as the x coordinates become more and more negative, the y coordinates become very close to equaling 2/3. That's a left horizontal asymptote. As Sam, I believe, said earlier, the right horizontal asymptote would be identical. Questions? Yeah, please.
Can you explain that one more time why the right's different from the left?
I may have said it badly. The right and left will be the same horizontal asymptote because we're dealing with basically the ratio of power functions. If we're only dealing with the ratio of power functions, right and left will be identical. Is that what you needed? 3 more, please, Jenna.
I'm confused how you know that 2/3 is. Yes, it is.
No worries. Are you comfortable with this fact, Sienna? that as we take the formula for F and we plug into that formula X values that are increasingly negative. Okay, yes or no, either answer is fine, Sienna. Are you comfortable that as that happens, these Y values get closer and closer to equaling 2/3? Does that feel comfortable? If not, just say no. Sort of.
Yeah, I understand.
What's happening is, were you okay? Did it make any sense that instead of finding the limit of this thing, we decided to find the limit of this thing here? Did that make sense?
Yeah.
Okay. This 2 and this X, Sienna, are they factors or are they terms? So terms would mean they're adding together. So it'd be like 2 plus X. So they're factors because they're multiplied. Same with the 3X. Good there. That means I can separate them only because they're factors. Because when you have one fraction times another, the fractions would multiply straight across, like 2 times X, 3 times X, the same thing. So now I can see that, oh, wait a minute. It doesn't really matter what X I pick. The yellow box will be 1. X can get as negative as you want. The yellow box is still 1. 1 times 2/3 would just be 2/3. So that means as we pick X coordinates that are more and more negative, the Y coordinate that goes with the X coordinate becomes closer and closer to a Y value of 2/3. Okay, let's see if this helps. We talked about how, I said to Elise, when you get a graph like this, where these Y coordinates are the same and there's one missing in the middle, they just gave a name to that thing. They called that a removable discontinuity. When we observed this behavior, someone wanted to name it. So they gave it the name left horizontal asymptote. Left because these X coordinates are very left on the graph. That's just the name they gave it. Anybody else? Stop the video. Oh, we didn't do the conclusion. So you'd say, therefore, f of x has a left horizontal asymptote if I ever answer a question in class and you really don't feel comfortable, just either stay after, come at lunch, come after school, do something to get your question answered. If you come lunch before after school, the group is smaller and it's easier for me to help you feel comfortable with really understanding, but you've got to understand it. If you just ignore it, it's going to cause problems. At a y value, not x, y value of 2/3. Not x, y.
So why is it 2/3?
So,
Why, sorry.
you're good. Did this table make any sense to you?
Yes.
Okay, so back to what I was saying to Sienna. Really, just think of it as a name someone gave to this situation, that if the x coordinates become increasingly negative, that's why they call it a left horizontal asymptote. Does that make sense? Well, it's like I said, this whole class is about understanding what happens to a bunch of number pairs. And in this example, the number pairs, one column is getting more and more negative. The x's are getting more and more negative. But what are the y values doing? They're actually just getting closer and closer to 2/3. So it's the y value that's getting close to 2/3. Therefore, we must specify that the asymptote is at a y value. Two more. Any other questions here? Oh, please.
If it was not like a horizontal asymptote, would our answer just be undefined?
Oh, awesome. Hey, look up. Good job. Sam's question was, you're supposed to be checking if there's a left horizontal asymptote, okay? If this problem had one minor difference, So watch close. This is how they get you on a test. They just change something a little bit. Say that was squared, okay? When we compared terms that added, raise your hand, please don't say it out loud. Would we have ended up right here, or would have something else happened? Hands up. So we still would compare terms that add, because we're still finding the limit. Would we have ended up with this blue box if we had started with this black box? Or would we have ended up with something different because of the square? Hands up. Who knows? Would it be the same? Like, would we get from black to blue? Would it be what I just drew? I put a little 2 there. Or would something else have happened when we compared terms that add? Hands up. Your hand is raised. Give yourself 2. Nathan, what do you think?
Be different.
So what would we get instead?
I mean, your final answer wouldn't it be like 2x over 3?
Oh, you're on the right track. You're perfectly on the right track. So from here to here would be good, right?
Yeah.
When we get down to this line, we have an extra x right here.
Yeah.
You with me? 3 points for Nathan. Is everybody with me? Okay, watch what happens now, though. 2/3 is still 2/3. It doesn't matter how negative x becomes, the yellow box is still 1. 2/3 times 1 is, say it, 2/3. But then you're going to be multiplying by a very negative number. It gets more and more and more and more negative. So the table won't do what you see here. The x's will become very, very negative. So will the y values. They'll just become more and more negative. Therefore, the limit would have been negative infinity, and your conclusion would have simply, there's not an undefined thing. You would just say f of x does not have a horizontal asymptote.
Just to check,
Yeah,
so
please.
when you're going from like the black box to the blue box, that like
Yeah, that didn't change because the comparison didn't change at all.
I just like squared them.
Yep, didn't matter. Yeah, the comparison was the same. It kind of came out awkward when I tried to ask the question. Yeah, is that fair?
I know what
I didn't- People didn't quite follow what I was saying. But that step's the same. It's when you go to here that it's different.
Yeah.
So, cool. Question. Your bell's gonna ring in like 30 seconds. We'll stop the video.